This is Lesson 3, Composite Graphs of Chapter 2 of the Edexcel book, Graphs and Functions. So we're going to look today at composite functions, which is something you looked at GCSE and may not remember. And what we're going to do is apply multiple functions in succession to an input, and the combined functions are therefore known as a composite function. And first we're going to look at the notation, or look at a mapping. So x has gone to f of x, then we've applied the function g to it, and we have g f of x. And you'll notice that we work from right to left. So we start, the inner function is f, and then we go on to the g. We don't do the g first. So the writing is the opposite way to the way we write normally. So g f of x means g of f of x, i.e. f is applied first, then g. So I'm going to make f of x be x squared plus 1 and g of x be 4x minus 2. So f g of the number 2. So we're going to apply g first, then f. If I apply g first, g with the number 2 is going to give me 6, and then I square that number and add 1, and I get 37. So now let's look at fg of x, just x. So here I'm just putting an x in. So fg of x means f of 4x minus 2. This 4x minus 2 is our new x part, so we replace that in the equation by the x by 4x minus 2 in the equation. So it's 4x minus 2 all squared plus 1. If we multiply out and tidy it up, we'll get 16x squared minus 16x plus 5. So what I've done here is I've replaced any instant of x in the outer function with the inner function. So the g of x is what I would call the inner function, and the f part is the outer function. So for this question, I'm doing exactly the same, but in reverse order. So I'm going to apply f first, and then I'm going to apply g to whatever f has outputted. So it's g of f of x. So my f of x is x squared plus 1, and therefore I'm going to, this now is the x squared plus 1 is my new x. So I've got 4 brackets x squared plus 1 minus 2. And if I tidy that up a bit, I get 4x squared plus 2. Now here, I've got slightly different notation. I've got f2x, which means, it doesn't mean squared, it means do f twice. So it's not a squared function, it is f of x. So if I do f of x, I've got x squared plus 1 all squared plus 1. Now I come to what we're going to be doing mostly in exams, which is solving these. So I'm solving g f of x is 38. So what I do is I first find out what g f of x is. And from a previous answer, g f of x is 4x squared plus 2. So I set that equal to 38. And I get x is equal to plus or minus 3. So for this one, for this last one, I've used the second from the last function and set the answer to 38. So here I've got these functions f and g are defined by f such that x maps to the modulus of 2x minus 8, and g maps to x plus 1 all divided by 2. I want to find firstly what happens when I apply the function f to g3, and then I want to solve this function, when I apply the function f to g of x, and it equals x. So the first one's fairly straightforward. I've got to do, this means f g of 3. Well, if I put 3 into that, I get 3 plus 1 over 2, which gives me 2. And f2 becomes 2 times 2 is 4. Take 8 gives me minus 4. And the modulus of that is 4. Now I want to solve f of g of x equals x. So the first thing I do is I find out what the composite function will look like. So my g of x is x plus 1 over 2, and I'm applying f to that. And my f to that is to take the x part, which is in the brackets, multiply it by 2 and take 8. When I do a little bit of tidying up, I get x plus 1 take 8, which gives me x take 7, which is again in the modulus function. So now I draw the graph of x take 7. And if I draw this graph, when I get to the line here, because this will cross at -7, I will dot down and I'll reflect up. So I've created my modulus graph. And now I put the line y equals x in it. These two lines are parallel, so therefore there's only going to be one solution because they both have the same gradient. So it crosses when on the negative arm of the modulus function. So where the modulus function is 7 minus x. So 7 minus x has got to equal x, so x has got to be 3.5. So test your understanding. So this is using, again, a couple of exam questions from the old syllabus, but they're very like what will appear in the new syllabus, or the syllabus you're doing. So we'll first look at the 2013. The functions f and g are given by f of x is 2 times modulus x plus 3, and x is in the real set of numbers. And g of x, g is such that x maps onto 3 minus 4x, and x is also in the real set of numbers. Find fg of 1. So, fg of 1. So we have to find g of 1 first, get that result, and then apply f to it. So to do that, g of 1 will give me -1, and f of -1 will give me 2 times the modulus of -1 plus 3. Well, the modulus of -1 is 1, so it's 2 times 1 plus 3 is 5. Now I want to solve an equation. G of x, so I find g of x and then reapply g to it, and I add g of x, and then I square what I get of g of x. And I want to find out when that equals 0. So to do this, I'm going to do 3 minus, there's my g of x, plus my g of x is 3 minus 4x, all squared. So I'm just going to replace my g of x in that function by this. Then I'm going to write it all out fairly neatly and tidily, or all out in this form, tidy it up, and eventually I will get to either x being 0 or 0.5. So I'll give you a few seconds to look at that. I would pause and have a look through that. So this again is taken as part from a question. Functions defined of x, f, such that x maps to e of x plus 2, x is in the real set of numbers, and g such that x maps to ln x, and x has to be bigger than 0. Find fg of x, giving your answer in its simplest form. So if we find g of x first, we get ln x, and then what we've got to do is take, so here we've got fg of x, we've got f of ln x, we've got e ln x plus 2. Well, the e and the ln basically are the opposite of each other, so I end up with just x. So I've got x plus 2, so they're inverse functions, they cancel each other out. So I'm just left with x plus 2, which is a lovely little question. So exercise 2C, pages 34 to 35. I'm also including on the PowerPoint some extension questions, and the next slide will show you how to do the answers to the extension questions. I'm not going through them, and I expect the majority of you to look at these extension questions and go thanks, but no thanks. They are really aimed at those of you who are thinking of taking perhaps step papers at the end of the year.